Hey Bobcats, I hope you're doing well. Today we're going to look at that data that you collected for the coin flip. So I'm going to start with one person's set of data. What happens when you guys fill out a Google form is it loads a spreadsheet for me with every set of data that you included, every question that you answered. And so I was able to take that form and then and get some raw data from it. So let's take a look at the students' data. They flipped heads 21 times and tails 29 times. So we know that the theoretical probability for flipping heads or tails is 50-50 or 0.5. So I'm going to go ahead and type in what I already know the theoretical probability is. Remember, theory means, like, in theory, you should be flipping it about half the time heads, half the time tails. Experimental probability is the probability that you calculate when you actually run the experiment yourself. And how does that compare to theoretical probability? So for the experimental probability, for heads, we're going to do 21. And if you don't know this already, Sheets is like one huge calculator. It is really awesome because it's not like a calculator where you need to put things in each time. Once you write a formula, if I go back and change the data, I don't have to do anything. It automatically updates. And I'll show you what that looks like in the next, on the next couple pages. So experimental probability for heads, 21, so I'm going to say equals, this is the start of our equation, equals A1, or A2 actually, sorry, A2 is the cell right here where that number is. And we know we're going to divide it by 50 because we know that the coin was flipped 50 times. So that means that our experimental probability, instead of being 0.5, it's a little lower, it's 0.42. We're going to do the same thing with heads. In fact, I can actually copy this, and it's so smart that it will automatically know that when I copy it here, I'm talking about the next column over and give us the probability for tails. So the experimental probability for flipping tails is a little higher, it's 0.58. Okay, now there's this formula that we can use to talk about how precise the experiment was, and it's called percent error. If we were not in this pandemic right now, you would learn how to calculate it. But since we are in this pandemic, I'm just going to show you and tell you what it means, but you don't actually need to calculate it yourself. I'll show you the results. So there's a formula for this, for finding percent error. So it's equals, and I'm going to subtract the experimental probability, which is in E4, and the theoretical probability, which is in E3. Then I'm going to divide by the theoretical probability, which again is E3. And then I'm going to multiply by 100 so that we can say that this is a percent. Okay. So what we're saying is this is a 16% error. We won't get into the negative. It doesn't pertain to what we're talking about today. So 16% error, the lower percent error that you get, the closer to theoretical probability it is. The larger it is, the larger the percent is, the further away from the theoretical probability it is. So let's go ahead and then calculate this. I'm going to copy it and paste it over so that it automatically does this. Now, here's the deal. The percent error is going to be the same for both heads and tails because it was the same experiment. Okay, so the percent error for this student's set of data is 16%. Now let's go ahead and take a look at a whole class set of data. So here we have a class. The first thing I'm going to do is I'm going to browse through the data and throw out any sets of data that didn't follow the rules. So if somebody didn't flip the coin 50 times, then we're going to throw that data out because it needs to be precise. So I can already see right here, look at this one. This adds to 45, not 50. So we're going to go ahead and delete that set of data. Let's see. I'm not sure how somebody got heads 46 times. I don't think I could do that even if I tried. And since I'm browsing through it quickly, I might miss something, but I'm trying not to. Somebody did heads 3 times and tails 3 times. That's not gonna work for us. Everything else looks pretty good. So now the first thing we're going to do is we're going to write in a formula for finding the mean. So we're going to add up all the sets of data and then divide by how many sets there are. So in this case, there are 23 sets of data because we don't count that first row because that was the title, heads and tails. So I'm going to put equals. And when I want to add up a whole bunch of numbers, I type in sum because it adds everything up. And then I'm going to go A2 because that's the first cell that has our data. And I'm going to put a colon, and then I'm going to say A24 parentheses. So now what's happened, you can see the orange lines around this set of data. That means that whole set of data is being added up. Now we know to find mean, we need to divide by how many sets of data there are. And in this case, there's 23. So that means that on average, people flipped heads 27 times. Okay, so I'm going to copy this formula and I'm going to paste it over here, and it's going to automatically calculate the tails for us, which is about 23 flips out of 50 for the average. Well, we already know the theoretical probability is 0.5, so I'm going to put that in, and 0.5. And then experimental probability, we're going to take that mean right here that we found. So this cell is, we're going to do equals E16 divided by how many flips there were, which was 50. And so the experimental probability for one class is 0.54 and so on. I'm going to copy it over. And you can see that the experimental probability for tails is a little bit lower than 50%. So it's 0.5 or 0.458, so on. Now we're going to calculate the percent error. So if you remember from the last sheet, we're going to do experimental probability. So that's in cell E18. Subtract the theoretical probability, which is E16. Oops, nope, it's E17. I had that wrong. We're going to divide by the theoretical probability, which is E17, and then we're going to multiply by 100 to get a percent. Okay, so notice that the percent error on this is smaller than the other page. When we were just looking at one set of data from one student, that percent error was 16%. For a whole class, it's gone down. We're getting a little closer to that theoretical probability. It's now 8%. Okay, so I'm going to copy this over, paste it, and again, it should be the same because it's the same experimental data. Okay, so it seems like the more sets of data we have, the closer to the theoretical probability we're getting. That percent error is getting smaller. So now let's look at all the classes together. All right, so again, we're going to go through and throw out any bad data. This one again. Okay, so this does include the class that we just looked at and all the other classes as well. Okay, you can see the 3, that one, and we're going to go ahead and delete. Somebody probably just put that in by error. Pretty good. I'm sorry, this takes a minute. Okay, so this is 24, 24. That means they flipped it 28 times. So we're going to throw that set of data out. I know this probably is not the most exciting lesson. I just get really excited about using Google Sheets, and I kind of wish we had some time at the end of the class to spend some time learning about it. But with this COVID-19 stuff, our hands are tied. But it's super cool if you ever get the opportunity just to play around in Sheets. You can do so much. You can do so much with it. All right, our set of data is clean now. So the first thing I'm going to do is I'm going to find the mean. So I'm going to do equal. And remember, I'm going to use sum because that's going to add up all of that set of data. We started with A2 as the first set of data. And the last set of data is A80. And you can see it has a nice orange line around it, so you know it's got all those sets of data. And because it goes down to 80, I know that there are 79 sets of data. All right, so on average, people flipped heads a little more than half the time. Just a little, by a little bit. It's like so like 8/10 more or 9/10 more. So I'm going to copy this and I'm going to paste it over here. So heads seems to be the favorite. Now the theoretical probability we know is 0.5, so 5/10. And then we're going to now use the mean to find the experimental probability. So we're going to take the mean, which is E, so equals E76. And we are going to divide by 50 because it's out of 50 flips. And then I'm going to copy it. Come over here and paste. And then I'm going to find the percent error. Okay, so when you're looking at the heads and tails here, the experimental probability, you can see that as we have more sets of data, we're getting closer and closer to 0.5. And you know, it makes you wonder, like, if I were to keep doing this, if I were to have every student in the school flip it 50 times, are we going to get exactly 50-50? I don't know. It would be interesting to see though, right? Okay, percent error. So to find percent error, we're going to do our equal sign. I subtract experimental probability, so E78, and our theoretical probability, E77. I'm going to divide by the theoretical probability, E77. Then I'm going to multiply by 100 to turn it into a percent. Okay. Look how low that is. It's only like 3.5%. So we definitely are getting closer to zero on that. And the closer to zero you are with that percent error, that means the more accurate your experiment was to the theoretical probability. And so I hope I didn't bore you to death, and I hope you found sheets interesting because actually I will show you one thing real quick. So notice that this is 17 and 33. If I were to change this set of data, I want you to watch the mean and all of these numbers are going to change. Okay, let's say that I did heads 40 times. It's going to change. And tails 10 times. So what I love about Sheets is it automatically recalculated everything. You didn't have to go back and redo that formula. It's just there. So let me fix that again and put it back the way that it was. So anyways, I hope I didn't bore you. And yes, Sheets is super exciting and interesting, and I wish we had more time to spend on it. But there you go. We compared theoretical probability and experimental probability. Go ahead and fill out the just quick 2 questions in Google Forms and submit that, and I'll know that you're good to go. Have a great day, Bobcats. Let me know if you have any questions.